distinguished delegates, eminent speakers, experts from the industry, fellow ICATians, ladies and gentlemen, a very good morning to all of you. I, Astha Dwivedi, on the behalf of International Center for Automotive Technology and Aspire Management, extend a very warm welcome to all of you for joining in the webinar on artificial intelligence and connected vehicles. International Center for Automotive Technology, ICAT, located in Northern Automotive Hub of India, is a leading world-class automotive testing, certification and R&D service provider under the aegis of NATRIP, Government of India. Aspire is a technology platform. Aspire stands for Automotive Solutions Portal for Industry, Research and Education. Aspire has taken an initiative of conducting the webinars on various topics, which is a part of celebration of Azadi Ka Amrit Mahotsav, which is 75th anniversary of our independence, of aiming to reinforce the Atmanirbhar Bharat in technology area. It is our privilege to have you all with us today for this webinar. It is the roots of any tree that decides how actually rise it will. Through this webinar, we have set a virtual stage to connect the industries, indulge and acquaint ourselves with emerging artificial intelligence technologies and its strengths. We will start with the main presentation now. We have two presentations followed by question and answer session. If you have any question during presentation, I would request you all to kindly write them in question and answer section with the name of the speaker they are addressed to, and we will take those questions on your behalf after all the presentations. I would request now all the speakers of the session to kindly keep their presentation ready. I'm sure the immense knowledge in the presentation will give us better understanding in artificial intelligence and connected vehicles. For the first presentation of the session, please join me to welcome Mr. Rajendra Khile. He serves as General Manager, Technical Regulation, Homologation and Technical Affairs at Renault Nissan Technology and Business Center, India. 23 years of experience in auto industry. Prior to Renault Nissan, he worked with General Motors and Tata Motors. He is chairman of regulatory panels on multiple automotive industry standards, member of various regulation formulation committee under AIS, BIS and India RDE. He represented Indian industry during United Nations WP29 informal group on heavy duty hybrid vehicles in 2010 and published two informal papers. He is involved in SAE India activities, worked as member of SAE India Automotive Board and keynote speaker for various SAE events, including Visita 2018, Newgen, etc. He holds his bachelor degree in mechanical engineering from Institute of Engineering and post-graduation course in automobile engineering from the ICAT. Now, I would like to invite Mr. Rajendra Khile to proceed for the presentation. Please.
Thank you. Hope I'm audible, Aditi.
Yes, sir, you are audible.
And hope my screen is visible.
Yes, sir. You may continue.
Okay. So, good morning, all. I will take you through the connected vehicles, a very interesting topic or a buzzword in automobile nowadays. So, basically, if we just start with how the technology is moving, very interesting statistics, which shows that mobile phone took 12 years for reaching a 50 million customers worldwide, whereas the internet took 7 years, Facebook 4 years, WeChat or 1 year, and Pokemon took 19 days. What it means is the rate of technology adoption is moving very, very fast and phenomenal change is there. So you are, I think, majority of the students, so you are all on the age of the internet and all. But if you check with your family or the older members, they may not be so adaptive to the technology. But you guys are good and you are very adaptive to new technology. Yes, and that's what is changing the world very fast now. So these are the mega trends worldwide. I'll not take you through all, but yes, the data or the data is becoming new gold. It's what we say. And in the global mega trends, you can broadly see that 90% of the world data, which will create in next 2 years, meaning what has been created historically in decades, will be only 10% and 90% in next 2 years. 1 trillion objects will get connected by 2022, and I think automotive is doing a good beginning here already. And the 66% of the world is connected at any time by 2030. What it means is the connected is going to be the future, and yes, data is going to be the key for the future. That's very important as we go forward. What are the social driving factors of the mega trends? If you typically in the mobility side, one is the accidents. Yes, we have 1.3 million fatalities globally, which is zero point 0.6 trillion cost, which is being because of all these fatalities. And unfortunately, we are amongst the major contributors. India, we have 1.5 lakh fatalities every year. So 1.5 lakh people uh, lose their life in the accidents. Congestion is second big issue. I think you all are staying in cities, so you know what the congestion cost is. Yes, so there was some relief during COVID period, and there was very little congestion, so life was quite different. I personally experienced where it takes to take 2 hours. Now I could travel sometimes in 30 to 40 minutes. So that's the congestion cost of the time spent and the fuel spent and the carbon emission increased. Yes, auto business models, typically what is said is to carry one person, it's a huge vehicle which we move. So it's that way oversized and underutilized if you don't really use it fully with all the passengers, which means there is a huge potential of a shared mobility. Yes, due to COVID, it has impacted suddenly. However, there is surely need to go for the shared mobility in the future if the automotive has to be sustained in the long term future. What are the current when we talk automotive sustainability today, we talk about utilization, production, sale, insurance, maintenance, repair, accident historically. So these are all the aspects of automotive or the mobility solutions from the decade or the century year old. But now it changes completely. What it changes is with the mega trends, it becomes electrification, it becomes connectivity, it is mobility as a solution. Even I think many of you 2 years before may be thinking there is no need to buy a car. I can always hire a car and just take a mobility service rather than owning it as asset. So this is definitely a mega trend going forward. Autonomous driving, yes, I think as the shared mobility goes and there is a less interest in driving rather than using it as a mobility service, there is a big opportunity, and I think there's a lot of movement globally on autonomous driving. Yes, it has still to reach the level 5, which is full driverless driving, but yes, we are not far away from it. So what are the key drivers in the technology in automotive? One is the Internet of Vehicles, which I think no need much explanation. We'll cover what is the V2X or what is the V2 EV in the subsequent presentation. Yes, we had a smart sensors, radars, cameras, the GPS, and all those servers which really help to make it a more intelligent vehicle. I'll not talk much on the technical part of sensors because Dr. Joshi will be anyway taking care of a AI part of it, where everything else will come. Autonomous drivings, which includes all these servers and then the utility through this server, the sensors. AI, I think Dr. Joshi will take in detail, so I don't take it. Yes, there is a big data, so there is a huge data will get generated. This data can help in rearranging the certain aspects of the mobility ecosystem, and we may get it. So I just share you one of the example in one of the OEM employee buses fleets. So there was a big data generated on the bus fleets, and which used to transport the employee. It was done for OEM who has like 25,000 employees to be transported daily. And then when the whole data was analyzed, there was a big opportunity of rerouting the timings, everything. And believe me, it saved straightforward just by the data analysis and rerouting the whole transport pickup points and everything. It saved something around 15 to 20% of the cost of the transport of employees. So it is huge benefit. I think today you are in colleges, when you move to industry, 1% is a huge savings, and it is not just a money saving, it is you get a more value for the same money. So when you get a more value for the same money, then obviously the business can flourish and it can improve in much better way. Then yes, definitely the blockchain's augmented reality and electrification are the drivers. On the now coming to the connected car, what we had earlier was the bare vehicle. Then we had some intelligent part, like they were software for engine management system or the vehicle body management system. Now from that we are moving to the connected vehicle, where we have internal monitoring and internet connectivity. With this, now we'll be moving a step ahead, which will be really a mobility ecosystem and full interconnectivity vehicle, where the vehicles will be connected with the other vehicle will be like you have in a uh, flights. The flights are actually interconnected with each other, and when you move on the flight, the two pilots can actually speak with each other. So it is not about speaking, but it is about communicating messages, communicating the concerns. If even in future, if suddenly there is a failure in a front vehicle, it may alert and give a SOS to other vehicles. So that's what is the full mobility ecosystem going forward in the future, and this is how the technology will move. So when we talk the whole ecosystem, it will basically remain. Vehicle will get connected to other vehicles, vehicle will get connected to the servers, vehicle will get connected to the backend systems, to the signaling systems, clouds, and yes, the 5G is one of the important aspects when we need to have all the vehicle connected and a very huge data in a very fast mode to be transferred. So this gives all the applications to provider, platform provider, network, and services. I'll not go in much detail of it, more theoretical slide, but it explains what is the onboard part of the vehicle and what is the offboard part of vehicle, which connects with the cloud services, data analytics, infrastructure, and internal. It links to the all these safety features, softwares, hardware, sensors, and obviously cyber security has to be in the part of onboard model, which has to be built in the vehicle system, so the hacking becomes difficult. I think you guys are all knowing that hacking is not something impossible, but yes, you can keep more security, which can minimize the risk of hacking. The connected car broader components are vehicle with the telematics units. Then yes, it connects with the mobile and GPS service providers. Then there is a cloud where the application with the algorithms can be there, and then there will be end customer application, mobile applications. I think this is not new. Already there are vehicles which are having this. And yes, there will be sales and service platforms. So even there are algorithms by vehicle driving, they can estimate what type of service is needed, and it may alert you that okay, your vehicle needs oil change. So that's not something impossible now. So broadly, okay, what it means, because everything has to be linked with economics. You are all engineers, but when you move it to the industry, you will know that each thing has to connected to the economics, and it has to make economic sense. Otherwise, the technology cannot move forward, or it will become stagnant. So technology to flourish, it needs to make economic sense. So what it makes is basically, if you know, the vehicle occupy third living space. So on the all the living entities, automotive really take lot of space where you talk about the parking issues. Then yes, the retail store, transaction platforms, personal assistance, the connected ecosystem can provide the learning, and yes, the relaxation phase, everything. So a high level estimate by Cisco says that for the automotive OEM, it can generate around roughly a $300 revenue per vehicle, and for a customer, it could broadly result because of the fuel saving, the accidents, everything. On an average per customer, it's expected it will save around 1,000 to 1,200 cost. So today, if you take a normal vehicle cost, it will be a very larger chunk, almost 10 to 20% of it. So now coming to what is the connected cars, or what is the V2X we talk about. So if we see in the connected car, there are four broader aspects, broadly called as V2X. But yes, vehicle to vehicle, vehicle to infrastructure, vehicle to pedestrian, and vehicle to business. So when we talk about vehicle to vehicle, it is accident prevention, which can be achieved with advanced safety, which is called as a frontal collision warning system. Meaning, if you have a vehicle in front of you and driver is not attentive to brake on the right time, the vehicle will give you warning that you are likely to have a collision now. And yes, because of this, they will be alert like a steering vibration or something. And if the driver doesn't act, then the next thing in the ADAS feature called as ABS, which is advanced emergency braking. If you are not braking, then the vehicle can brake on its own. So where basically it detects the front vehicle speed, it detects the distance, then the algorithm really calculates whether there is sudden deceleration in the front vehicle, or the distance between two vehicles is reducing with a uh, certain deceleration rate, and accordingly it can take a call, and it can take a call with what level it has to decelerate. So what level of braking has to apply based on the situation. Also, such calls will be taken by the vehicle. So uh, meaning theoretically it mean okay, then I can be very relaxed in the car. But yes, the technology is not mature that you can be completely ignorant what is happening. It expects you to be attentive in the car. But yes, there in the future it may be very mature. Today, yes, there are certain issues, like if there is a sudden change in the traffic behavior, for example, you're driving, so vehicle can detect the front car or a motorbiker or something. But if there are maneuvers, like somebody suddenly comes in between, then maybe the technology is not that mature. It can react so fast. For that, yes, it will need a very faster algorithms. It will need a faster net speed, data transfer speeds, and I think moving with 5G and higher speeds, maybe the solutions can come in picture. But today also broadly it can take care of the uh, obstacles coming on the way, and it can break. Then comes the next technology, which is lane keep assist, or lane warning system. There are various names. I'll not go in names, but what it means practically is you detect the lane marking on the road, and based on the lane marking, are you permitted to really cross the lane. So if you are not permitted to cross the lane, it will give you alert that you are there is you are trying to cross the lane which you are not supposed to. Then it can even if you are unintentionally crossing the lane, then the vehicle has the systems, and it can actually correct the correction. It can do the correction to keep you in the lane. Yes, and then further there is something called as adaptive cruise control, where you set the speeds and the vehicle will intentionally work on your speeds, but if there are obstacles, it can reduce the speeds according to the traffic, and again try to reach the targeted speeds whenever there is a free road. So you can be simply the pedal, you need not to really do so much pedaling or acceleration or braking. So vehicle can take care on the highways, typically not in a very density traffic as of now, but on highways it is a very useful function. Then something from called as a uh, intelligent speed assist. It's a ISA, it's not ASA. Sorry for the error. So intelligent speed assist means on the highway it can read there is a sign that the speed limit is 50. The vehicle can understand that the road needs a 50 speed limit, and then the vehicle will ensure that you will not go beyond 50. So as you know now, India government also quite seriously has increased huge penalties for breaking the speed and everything. So and even if you have no intention to cross the speed, unintentionally sometimes you may cross the speed and end up in challan or some accidents there. When the speed is set on a road, it means something, because infrastructure is developed for that speed. Though your vehicle can go for faster speed, but infrastructure, because of the road condition, traffic condition, uh, demographics, having school there has certain limitations. So this technology in the connected vehicles can help you to control the speeds. Then definitely travel time reduction it can do when there is a V2V communication. There could be indications about the issues, and yes, there are extended driving visions, which is something called as 360 vision, night vision, the parking sensors. They also help you a lot of safety as well as ease of driving and ease of getting a better vision. Even there are certain blind spot in a vehicle, there are certain zones from where you cannot see, so the sensors or the V2V can help you in getting that information. Then comes to vehicle to infrastructure communication. So yes, the traffic signals can talk to vehicle or vehicle can talk to traffic signals, meaning you'll understand when the signal can decide whether really I need to wait because there is no traffic. It can take a call based on traffic situation. Yes, it can alert you that there are certain places through the backend server, which today also available in somewhat way through the Google Maps, but what is there in a long run with the connected cars will be much realistic than the Google Maps. Yes, Google Maps are improving in a very big way, but you know the incidents which has happened and very publicized. Somebody just put mobile phones in a trolley and moved. So that's fully manipulated the whole Google Map, because it's not working directly on the vehicle, it's not on traffic, it's working on the mobile of the traffic user. Whereas the new system with the vehicle connected car, it will be actually on the vehicle movement, and then it can differentiate these type of issues, and it can really give a very real life information. Yes, the weather advisories can be issued, vehicle can be connected to the servers where they will get the weather advisory message, traffic light status. Then coming to even pedestrians, the vehicle can detect and protect the pedestrians uh, in case for the safety. And very interesting one, which is called as vehicle to business, which I think we are not seeing it today, but it has started at the very initial phases. Whereas when you are driving, the vehicle can tell you all the offers. So imagine you are traveling somewhere in Cannot Place, and one of the shop has offer. Okay, so based on your interest, as you select, the vehicle can tell you, bus, you have a possibility. There is a parking slot available. Just park it there, and you wanted this item. It is available at this cost. So, or it can tell you, oh, you are tired, so you need a Starbucks coffee, and yes, there is a shop here, and there is a parking available here. Imagine it will be that future, maybe in a decade or 2 decades from now for India. But yes, it has started in developed world already. So connected car, okay, all this is a great future, but yes, any opportunity comes with the challenges, and those challenges are we need a ecosystem, we need such a reliable uh, data services at all the places. We need infrastructure to support all these. The sensor has to work under certain frequency. Today, those frequencies needs to be available for development. Yes, you all have heard about the semiconductor shortage. So now we need to see such technologies. The solutions are locally manufactured so that we have a sustainable ecosystem for it. Then yes, it can be manipulated also, as you all know, and there is a very interesting videos you might have seen already. So yes, somebody can just control all the traffic, and they can do whatever they want to do if the hackers do it. So this is a big challenge going forward. Yes, the personal data can be theft in vehicle. I think your mobile is doing it enough as of now, but with vehicle it will go on increasing further. Where you move, even with whom you move, everything will be on the servers, and there is a risk of hacking this. So globally there's a lot of churning going on. How do we get a benefit, same time we deal these challenges, how we ensure the data privacy, and yes, the cyber security issues. So globally there are a lot of developments. I think you all know it can't be nullified, but it can be reduced to a very large extent to take care of safety. Now coming to India, I think we talk much about the technology and the world. So in India, yes, are we doing something? Surely we are doing many things. I think Dr. Joshi is there. He is leading a lot of government panels for doing the connected car and ITS side of it. So one of two things which are already available in India, one is vehicle tracking system and FASTag. We will take you in detail about it, what is it in India, and then it can help you to realize what is the benefit. So you have something called as electronic toll collection. So we know the reality 2 years back or 3 years back, and now how easy it is to pass a toll booth. So, and it is a very simple technology, a very simple RFID tag worth maybe 50-60 rupees, and one RFID reader at the uh, toll plaza, and a backend system linked with your payment, your mobile app, your the wallets. Basically, it works with a wallet concept, and you are simply able to move out of the toll gate. There is no discussion, no waiting for the change, no waiting for the amount, and it detects your vehicle classification. If it is a car, it will reduce the lesser toll. If it is a truck, it will have a higher toll. So all that has become really easy. So this is a benefit. I think there has been studies going on how much really it has yielded for a country in term of fuel and time saved in the transport. But believe me, on the large junction, 10-15 minutes of a traffic jam was quite normal, which has really come. You are able to cross in 2 to 3 minutes. So I broadly see at least saving somewhat around 60 to 70% of the time at the toll booths. This is the benefit of connected vehicle or the technology. Then there is something called VLTD recently introduced, where vehicle location is tracked, and there is emergency or panic buttons in the car. And if you press the buttons, this is today for the transport vehicle, because this was initiated as a action post the Nirbhaya incident, and there was a technological solution being sought. So this is the solution I think has been offered. I think ICAT and Dr. Joshi had a great contribution while developing the whole this system, where the GPS tracks the vehicle location, and once the emergency button is pressed, the information goes to the backend room, and even if the police support or everything can be provided back to the vehicle if there is a some mishap between by the driver to the customers. This further can be integrated in future. If there is a crash, the crash sensor can tell the VLTD system and just trigger that yes, there is a problem. And yes, it can be further interactive as the technology moves. somebody can speak, and if they observe that there is no response, meaning there is a real crash happened, and yes, then the support with ambulance and everything can be provided. This is what is something called as e-call, which Europe has recently started, and I think near future India also may do it. So if you see what is the image in India we likely to see. So if you see on a typically on cars in a short term, we likely to see in 3 to 6 years a very broad penetration. I'm not talking about having the just technology in one or two model or some model, but broader cars you will see something called as a e-call, where in case of these accidents and all, the information can come and the ambulance also services can be provided. The seat belt reminders, where the all seats type of if you are not using the seat, there will be alert and reminders. Then the stability control, I think it's already getting popular much. Then the blind spot warning, because in the heavy vehicle this is a big issue, where certain vision is not clear and that causes accident. So we do see if there is a some obstacle in the blind spot of vehicle, the warning coming. Driver drowsiness, because we have one of the largest second largest reason for accident is called as a drunken driving, or the commercial drivers do operate for very long time, and there is always a risk they get tired. So the drowsiness sensor can detect whether you are alert or you're feeling dizziness or you're feeling sleepy, and yes, it can uh, first give you a warning, or in the next level of technology it can slowly take the vehicle outside the driving lanes and keep it in parking until you become alert. And yes, the forward collision warning, where the collision alerts are provided in buses and trucks. I think the regulation formulation is already at a quite a good level reached, and there are discussion to evaluate the market situation and then how to go for this technology. Long run, we see the lane departure warning, lane keep assist, AEBS coming, as well as the automatic, the other features of automotive connected vehicles. So yes, is this everything feature? No. We have already cars in India which has recently launched, where we have, if you see the first one, these features which is AEBS as well as frontal collision warning system, lane keep assist, then the adaptive cruise control, and the intelligent speed alert by watching the speed on map, the speed limits on map as well as the speed limit on road, and the vehicle can then adapt to the speed limit which is there, or give the alert that you are crossing the speed limit of the road. So this is how is the all technology about it. That's it from my side. So Aditya, I have one request. Due to certain emergencies internally, I will have to drop. So if possible, I would like to take the questions now, or maybe then you or Dr. Joshi can help answering the question, and you can take on email. We can even respond later through the email replies on the questions.
Thank you, sir. Thank you so much for your valuable time and presentation. It will help us all greatly. Now, for the second presentation of the session, please join me to welcome Dr. Madhusudan Joshi, DGM ICAT. He is the head of Electrical and Electronics Group at ICAT. He started his career with ARAI Pune in October 2003 and with ICAT for the last 18 years. He has worked on various R&D projects related to information security, intelligent vehicle technologies, electric mobility, and vehicular lighting systems. He has published more than 40 research papers in international journals, conferences, and symposiums. He has a co-applicant in 10 patents and 2 copyrights in different areas of his work. He is the vice chairman of sectional committee on ITS, an active member of BIS committees, e-mobility under TD27, automotive lighting, and automotive electronics. He has received his doctoral degree from Indian Institute of Technology, Delhi, in the field of optoelectronics. Now, I Dr. Madhusudan Joshi to proceed for the presentation. So, please.
So I'm going to speak about artificial intelligence for better tomorrow. My colleague from industry, Mr. Khile, has already made an elaborate presentation on connected vehicles. So nowadays, these technologies are non-separable. If you talk about artificial intelligence and then connectivity, and then 5G, mobile connectivity, etc. All these are kind of topics which cannot be separated from each other. So there will always be an amount of overlap. So I will try to focus more on artificial intelligence, and I wish I could have made it more interactive, but I don't know whether we will be able to discuss something maybe at the end of the presentations, or we have some interaction with the students at the end of the presentation. So let us see that. And but first of all, I would like to make this brief presentation, and then subsequently we can open the floor for question answers and interactions. So the contents of my presentation, I will speak a little bit about my organization, about ICAT, International Center for Automotive Technology. Then we will, I will discuss about some topics which are connected, like intelligence, human intelligence, and artificial intelligence. Then we'll talk about what is the basis of artificial intelligence, how the progression in artificial intelligence has happened over a period of time, what all different types of what are the classifications we can do as far as artificial intelligence is concerned, and how effective artificial intelligence is. Then a very interesting topic of, can artificial intelligence outperform humans? Artificial intelligence applications, and I'll be presenting a short case study which I found on internet as very interesting, as a logistics application of artificial intelligence in logistics, and then also citing some examples of artificial intelligence in transportation. So this is how the presentation is. So this is a photograph of International Center for Automotive Technology, which is based out of Manesar near Gurgaon in New Delhi. So we are actually a national agency under Ministry of Heavy Industries and Public Enterprises. Primary mandate is to test, validate, certify automotives. That's the primary mandate from Government of India, and we have about 15 different test laboratories where we perform these tests on various components, assemblies, sub-assemblies, and complete vehicles, starting from engine, transmission, testing emissions, testing various mechanical, electrical, electronic components of the vehicles, then testing systems having working on alternate fuel, CNG, LPG, etc. Then performing electromagnetic compatibility on various assemblies, components, subcomponents of the automotives. Then we have a facility for testing lighting devices, noise, vibration, harshness, pedestrian safety, which includes crash. Then a vehicle evaluation lab, a fatigue lab, a tire lab. Then we have test tracks and proving ground where we actually try to do the vehicle dynamics. And then we have a CAD-CE facility, computer-aided design and computer-aided engineering. So this is how we are organized as far as electrical electronics department, which I'm heading, is concerned. We have a facility which is state of the art for electromagnetic compatibility. Then we have electrical electronics lab which with alternate fuel test facility, which takes care of various components of the vehicle, specifically related to ITS, intelligent transportation system, connected vehicles, ADAS vehicles and also for electric vehicles. Then we have a facility which is there for testing light and light signaling devices, which are fitted on the cars and all different type of light fixtures, etc., which are available at the infrastructure level when we talk about automotives. So these are the primary areas of interest for us in electrical electronics group. We have started working on cyber security and functional safety. We work on ITS, battery and EV technology, then also doing some bit of work in artificial intelligence, but to a very less extent at the moment because it's picking up in the vehicle. So we are also trying to gear up to support our customers on this technology. Then we have interest in lighting. Lighting also is, as you know, in vehicles is coming as a very big subject, and also being linked to artificial intelligence and connected vehicles in a big way. So we have a state-of-the-art facility of lighting at ICAT. Okay, so just after this brief introduction about ICAT, I would like to, discuss starting with the definition what we call as intelligence. So what exactly the intelligence is? When we talk about intelligence, basically it's a very, very big umbrella terminology which encompasses many abilities as far as humans or maybe even animals are concerned. So depending upon the level of their intelligence, they have their capabilities to, do reasoning, do planning, to solve problems, to think, which is also a very big ability to think, comprehend ideas, use languages, phonics, etc., and also to learn. So this is what we try to define broadly as intelligence. Now, talking about these terminologies which we have been hearing, for instance, childhood is by intelligent quotient. How we try to objectively measure intelligence. So there is something called intelligent quotient, which we can obtain by, with a formula which is written, which is in front of you, which is mental age upon chronological age into 100. So normally these IQ levels can range between 80 to 120 in human beings, depending upon their mental ability. Similarly, emotional intelligence, which also encompasses many things like self-awareness, empathy, motivation, self-regulation, social skills, etc., where also apart from your brain intelligence, there is a connection with the emotional part, which is related to the heart of the human being. And when this is collectively being taken together, we talk about something which we define as emotional intelligence. So this also plays a very important role. Why I'm actually trying to make a mention of these topics is because we are going to talk about something. When we say, is artificial intelligence going to be so strong at some point of time, then it can outperform human beings? So this is the question, and these two definitions will help us in understanding whether it's going to happen someday or not. So we have to really discuss, can machines have these intelligent quotients or emotional intelligences in future? That is what is the point of discussion. Now, talking about the artificial intelligence, basically it's a branch of data science which actually focuses in building smart machines which can perform some tasks which actually require human intelligence and cognition, right? So some simple or some complex task which humans may take a long time to do because of their limitations, where machines can come in. These intelligent machines can try to do this job in a much efficient way, in a much organized way. That is what artificial intelligence is all about. Now, when we talk about these intelligent machines, normally they work on, they work on the basic principle of, using the experience and the data to, learn, acquire certain amount of knowledge, and also analyzing the surroundings and environment around them, and then try to use that training data, or what we call as the learning, in performing the actions which are supposed to they are asked to deliver. And in this, as the artificial intelligence is growing, uh, there are a lot of new things which are being used to design and develop these intelligent machines using artificial intelligence. So it is not the game is not that simple now. Artificially intelligent machines nowadays use computer science, cognitive science, linguistics, psychology, neuroscience, and mathematics. Now, this is something which scientists have been trying to do to make the artificial intelligence as possible to the human intelligence. So that is why these topics have also started picking up now. Now, the primary objective of artificial intelligence is to assist human, and by developing intelligent machines. So the typical examples of intelligent machines are chatbots. When you do nowadays interact with various commercial sites like Amazon, or maybe Policy Bazaar, or maybe with a banking system at State Bank of India or any other bank, there are chatbots with, who are artificially intelligent, being given a lot of training on various frequently asked questions, and you can pose a new question to them, and using their database and the training they had over a period of time, they can try to answer your questions which you can try to pose to them. Similarly, the smart virtual assistants like Alexa, or Google Echo, etc., Amazon Echo. So these are the virtual assistants which can be used to perform simpler tasks, which are actually kind of routine stuffs, which these systems can try to acquire knowledge by learning and training, and then try to respond to some new situations. Then surgical robots to perform very complicated surgeries nowadays, and self-driving cars. So these are typical examples of these artificially intelligent machines, which actually are involved in some kind of a decision making based on some predictive analysis and the training they had over a period of time. Now, what is the basis of artificial intelligence? So, I think the basis of artificial intelligence is very similar to the basis of human intelligence, where brain comes into picture, and all the inputs coming from various sensory organs to the brain, and then brain is doing a neurobiological kind of a process, which actually is quite complicated and very less understood at the moment. But fusing the various amount of information and data coming from these sensory organs to the brain tries to process it, and then after processing the data, it decides the adequate action, which is actually communicated to the actuators like hands, or in the form of the speech, or in the form of blinking of eye or something like that. So these are the actions which actually brain does. So similar kind of replication scientists are trying to do as far as artificial intelligence is concerned. Now, in this process of data communication and action, there's a very important processing being done by the brain, which is actually uh, uh, you know uh, which is really complicated. But somehow we have been able to design certain tools which actually kind of replicate the way human brain processes the information. And these tools basically are known as deep learning tools, which is a subset of artificial intelligence, which is subsequently has another subset called machine learning, and then deep learning, where we try to analyze the information coming from various variables and inputs, try to process that input, and trying to coming as close as to the realistic situation, or the solution. So typical methods of doing this is artificial neural network, which actually has a kind of schematic very similar to the human brain. Layer by layer processing happens, and we try to give an input, try to process that input through something, through the units which are known as neurons, typically similar to the neurons in the brain, and then try to come to an output Then going as a feedback, that output goes to the compares with the realistic input, realistic solution. If it is not close to a solution, that is back propagated, processed again, and then after rounds of iterations of doing this training and the prediction, training and prediction, training and prediction, it tries to come as close to the desired solution. So the idea is to do the continuous processing of information by using the training data and reducing the error in the final outcome. So that is the basic basis of artificial neural network. And similar kind of uh, similar kind of tool available to us is genetic algorithm, where we try to start with the initial population, working on the principle of Darwin's theory of survival of the fittest. We try to keep the useful information and delete the redundant information, then try to reproduce the desirable population to higher numbers, trying to understand what kind of outcome it gives. If the outcome is suitable, it's fine. Otherwise, go to rounds of iterations and try to again reach to a solution which is containing less errors and as close to as possible as to the realistic outcome which is expected from the machines. So this is the basis of AI, and there are a lot of other tools available apart from these two. This is just few examples I tried to pick. Then, as far as the progression of AI is concerned, there had been, chronological, advancement as far as AI is concerned. It has taken over a period of time since the time when it started way early 1950s, and then somewhere in 1960, late 70s, there were chatbots which were made, which were mechanical chatbots, then smart robots. Then over a period of time, we had some very smart machines which are actually like Deep Blue, which are made by IBM, where that machine was trained enough to even defeat the that time chess champion Gary Kasparov. And and as gradually smarter systems, another machine made by IBM, Watson, which was able to win a quiz show. It was that intelligent. It could have that memory and training that it could answer all the question posed during that quiz event, and IBM Watson was able to perform that task of and winning that eventually winning that quiz show. Then we had virtual assistants like Amazon Echo, or maybe Alexa, Siri, etc., being made in early 2014 or something. And then where we are now is looking at to a situation like the processing happens in our brain, lakhs and lakhs of inputs coming to the brain, and it is processing all the inputs simultaneously and then doing some actions. So similar kind of thing is happening in the third wave of artificial intelligence, where we try to learn by acquiring data from the cyberspace and process it, and then decide the final outcomes. Now, how effective and where AI can find its effectiveness is actually on some very special and precise topics like speed of execution. Wherever where there is a large computation involved, where human brains are not capable of doing those intensive calculations or computations, those can be the areas where artificial machines can come in, try to execute that information in a very good way, and predict the outcome. So these are straightforward problems, and then these machines basically are trained holistically, so they are less biased. Then they have a lot of operational ability, and they don't get tired as human beings does. So when we have something which involved a very laborious or a very high intensity computation or something, where there we can involve these machines which can run untiringly for months or so, then these machines can be very precise when being deployed to a particular application, where the system is very well understood and the machines have all the possible inputs already known to it, so it can design its structure in such a way internally that it tries to cover all the possible outcomes in a very accurate way. Then, last but not the least, artificially intelligent machines are very suitable for the applications which actually have to do some monotonous judgments, where a specific task repetitively have to be performed. Then artificial intelligence, can help in a very big way. Now, but is artificial intelligence self-sufficient? That is another question which we have to try to answer. You know, just try to think how the human brain works. It is not a simple computing processor where the inputs are coming, we are processing and giving the outcome. No. So there are a lot of other things which happen inside the brain, and so to say entire body which communicates with the brain. There are a lot of phenomena which are happening, such as something which is called combination of logic, or maybe reasoning, or judgment, or intuition, or emotion, accuracy, reflexes, and understanding. So these are things which we cannot expect from a machine, right? So this is something which is actually specific to only human beings, and which we cannot be expecting from a machine to have all these parameters which can be incorporated inside the machine, and then the, and then the there are certain concepts like learning, thinking, coaching someone, mentoring someone, guiding someone, supervising someone, or motivating someone. So these are further concepts which actually are fully absent in any kind of a machine. So this is specific to humans. So as far as the understanding goes, artificial intelligence can definitely find a place, and is going to come in a very big way, controlling a lot of things. But when it comes to replacing humans, that is something which is a far-fetched kind of a thought. Artificial intelligence can definitely be very useful, but can work very smartly and very efficiently under the human control. So that is what is my understanding of AI. So as far as AI is concerned, it's not really self-sufficient. Now, talking about the classifications of AI on the based on the capability can be classified as weak, general, and super AI. So we are nowhere close to super AI at the moment. It's going to be the highest form of AI, which is going to happen at some point of time, we expect. But as far as a weak and general AI is concerned, weak AIs normally are the typical examples are say a simple one is some tool like Alexa. So which has a very straightforward predictive model, and very easy to handle, and having very simplistic kind of algorithm which is running inside it. So these are the examples of weak AI, and the general AIs can be something like smart cars, smartphones, or maybe connected cars, or maybe a autonomous car. These can be a typical example of general AI, which have a much broader, much smarter algorithm running inside it, much better predictive modeling done. Many data can be fused with the help of that algorithm, and then outcome can be more accurate, and so to say more refined. So these are the classification based on the capability, and then talking about the functionality part, we can have something called a reactive reactive AI, which is very simple and straightforward. A question being asked, and machine calculates and gives the answer. Then there can be something which is a little smarter than it, limited memory, which has computing and processing power, and can work to some extent like human brains when we have to do some kind of logic on something has to be applied, similar to what we do in case of an autonomous car. Then the third level is theory of mind, where we get into more complicated business, where we have to talk about lot of possibilities together, try to fuse that information, and then having a predictive outcome out of it, which is which is much precise, much higher level. And then final one is the self-aware, which is very close to human being. And at some point of time, if we are going to reach this level, then of course the intelligence of those machines will be at par with human beings. Now, what are the different applications of AI? As you know that AI is everywhere, starting from smartphones to security surveillance, social media platform, Instagram, etc. Then navigation, e-commerce, banking, autonomous vehicles, and smart homes. In addition to that, AI finds its application in medical field, communication field, then logistics, etc., etc. So I'll try to pick one case study where we can typically explain how AI can help in as far as logistics is concerned. No, starting from planning stage, where where a logistics company is planning and forecasting the demand. So these are the topics from where we can start with. So you can see that there can be models which can be made around the artificial intelligence, where you know data can be analyzed and try to the forecasting can be done, that which product will be in demand maybe next month because of some activity, some festival coming or something like that. Then similarly, after this forecast, the planning of the logistics planning can be done to acquire the products which could be on high demand. So this is the type of role which AI can have in the planning part as far as logistics is concerned. Then coming about these material handling, and damage detection and predictive maintenance in the warehouse can also be done in a smarter way using robots. Nowadays we have smart robots which can be used to pick and store the various products at different places in the warehouse, and smartly pick them. Retrieval is also quite easy. Nowadays all these e-commerce companies are deploying robots inside the warehouses to effectively manage their inventory, and also do damage detection in case of in case some part is broken or something while storing these parts products. And a predictive maintenance can also be done, because a lot of data is being stored in the central servers related to the warehouse management, and this data can be analyzed using artificially intelligent systems, and a predictive maintenance schedule can be made in order to have better efficiency. Then talking about delivery part, now you must be hearing about delivery drones and self-driving vehicles being used in some limited pilot way, but soon once these technologies are kind of matured, then these can be used by logistics companies to efficiently deliver the products in a very shorter time and in an accurate way to your households. Then talking about analytics, this data which customer data and the data of sale purchase which the systems have in their server, these companies have in their servers, they can decide the dynamic pricing depending upon the demand and supply, and also the route optimization for their delivery channels to save time. Similarly, the data which is available can be used for automation and also for providing a good customer service to customer service through the chatbots, etc. Then about sales and marketing, depending upon the data available. So data is the key, as you may be able to understand. This data needs to be analyzed smartly by the artificially intelligent systems, and then this can be used in any field, starting from planning to sales and marketing. So all this can be done with the help of AI. Now talking about AI in transportation, the transportation finds a lot of applications as far as AI is concerned, starting from intelligent traffic management, connected vehicles, which Mr. Khile has already spoken, cloud services, driver monitoring, predictive maintenance of the vehicles, analysis of road and traffic conditions, analyzing pedestrian safety, and of course, autonomous vehicles. So, pedestrian, talking about pedestrian safety and intelligent traffic management system. As you know, the 5G connectivity is soon going to come, and we have a lot of artificial intelligence which is already in place. This combination of 5G with artificial intelligence can help to really to analyze the data at the various traffic signals, crossings, and intersections, etc. You know, to analyze that data from the point of view of pedestrians, from the point of view of vehicles, and sending this information back to the backend servers, try to do some damage control monitoring, etc., etc. And efficient traffic management can also be done using artificial intelligence, where we can decide, depending upon the traffic density, how the light signals should be operating, what frequency these should be operating, and whenever there is a pedestrian crossing, how the safety of the pedestrian can be ensured, using this real-time data. So that all is possible. So recently, initiative has been taken by Government of India, which is known as iRaste, where which is known as Intelligent Solutions for Road Safety through Technology and Engineering. This project basically is aimed at improving the traffic and the pedestrian safety. This has started as a pilot project in Nagpur, and once it is successfully deployed, then it can be we can find its application in various parts of the country to improve these situations. Then when we talk about analysis of the traffic conditions, AI is a very useful tool from that point of view, where we can try to analyze how the traffic flow happens in a given city during different parts of the day, and depending upon the traffic density, or maybe depending upon a situation when an accident happens at a particular location or something, the rerouting of the traffic can be done in a very intelligent way, where the commuters can save time, a lot of fuel can be saved, and a lot of efficiency can be brought in terms of managing the traffic. Similarly, as you know, the modern cars are being fitted with a lot of sensors already, starting from GPS and cameras and lidars, radars, etc., depending upon the model. So a lot of information and data can be collected normally through these sensors, and this data can be analyzed over a period of time by the artificially intelligent systems. And by analyzing this data, it is possible to decide about the predictive maintenance of the vehicle, which is also kind of we can say in simpler way, we can do the remote diagnostics, and some part of the troubleshooting can be also done remotely. And if there is a major breakdown being expected, then the car can be sent to the workshop well ahead of time. Then very important, interesting application of AI is the driver analytics, behavior analytics, where we can try to use the deep learning algorithms, etc., and taking inputs from various cameras and biometric sensors which are present in the vehicle to kind of understand whether the driver is driving rash, or he has some distractions, or he's feeling sleepy, or is drunk. So that can be analyzed, and based on that, corrective action can be taken by the enforcement, and the fatalities can be avoided. Connected vehicles, Mr. Khile has already spoken, so I would not be spending much time on it. But as you know, nowadays the cars are connected to some extent, and the various ways cars are communicating with other vehicles, will be communicating with other vehicles, or maybe with the pedestrians, or with infrastructure, or the government enforcement. Is also a very interesting topic, and is picking up gradually. I'm sorry, I think there's a timer to the slide. Automatically it's changing. So these are the various applications of AI. So as to conclude, I would like to say that AI has a very promising future in all sectors. It can improve the quality of life and ease of doing business drastically, provided it's being used in a nice way. And there will be a great demand of skilled professionals to work on AI technologies. And in my opinion, it is not. It is impossible for AI to, outperform humans at any point of time because of many reasons, as explained to you in the presentation. So thank you, and these are some publications which has been done from our department, which include publications on at international journals or conferences and patent copyright. So I would not like to go to the details of this. So thank you so much, and I welcome if there are any questions or any interaction which is required to be done. Thanks. Hello.
Hello, thank you, sir. Thank you for your valuable time. There's one question from our attendee, Mr. Harshit. How can AI robots act as humans?
As I explained, that's a good question. But as I explained to you that in order to design a machine like a robot which could act like human at some point of time, firstly, it is important to understand how human brain works. If someday scientists will be able to decode how the human brain processes the information, how it fuses information from various input sensors, which are sensory organs, and then also try to, process various other aspects of which I mentioned to you, the intuition, emotion, feelings, human touch, which we call. So when we understand that completely, possibly then somebody will be able to deploy that in a machine. So it is firstly important to understand how human brain works, and people are working, and we hope that someday we will be able to decode it, and then possibly there is a possibility that we will be able to design something which will be like humans.
Okay, and also another question from Mr. Ridhan Bansal. If an AI robot malfunctions, what are the causes and effects?
What are the consequences?
Yes, sir. What are the causes and effects of that?
The malfunction in a machine can happen due to many reasons. As you know, artificial intelligence systems basically when deployed inside a machine. So there is one part which is the computing part, which is the part which is analyzing the information and then suggesting the action to the actuator. And then there are sensors involved which are picking the information, giving to that computing system. So malfunction can happen anywhere. It can happen at the input side. It can happen in the output side. It can happen inside the computing system also, or then there can be a mechanical failure as well. Like failures can be of any type.
So another question from Mr. Harshit M. Rajani. Is AI really necessary for human life?
I mean, this is something which is unavoidable, because artificial intelligence is finding a place which actually is trying to supplement the human actions. So anything which is assisting human, cannot be overlooked. So that's a question which I would like to answer in the survey, that artificial intelligence is something which is going to come in a very big way, because it is finding place where, as a very good assistant to human being, simplifying his life.
Okay, now rest for the question answer session. Rest of the questions will be taken on your behalf and will be answered through email on your registered email IDs. Now, we on the behalf of Aspire and ICAT, once again thanks all the speakers of the session for gracing today's webinar with your presence and knowledge. Thank you all the delegates and attendees for your attention and active participation. I hope you found today's webinar informative and useful. Thank you all for signing in. And with this, I will be concluding this webinar. Stay healthy and stay safe.
Thank you.
Thank you so much.